Hello everyone! Today we'll explore the testing methods for ABS sensors. Modern motorcycles commonly feature ABS anti-lock braking systems and TCS traction control systems. For instance, the traction control system uses sensors to monitor wheel speed in real time, reducing acceleration time on slippery surfaces and minimizing body sway by approximately 62%. This high precision maintained within plus or minus 2% accuracy is crucial for safe driving, especially during high-speed maneuvers or emergencies. Take a look at this motorcycle's ABS sensor. Made of engineering plastic, it contains a Hall effect sensor and an electromagnetic coil. As the wheel rotates, the openings on the signal disc approach and recede, causing the sensor to detect changes and output varying voltages. This allows the ABS computer to determine the wheel's speed. If the ABS sensor probe is damaged or the wiring malfunctions, the ABS computer cannot detect wheel signals and will trigger a fault code. While this may not immediately affect your ride, it could lead to serious consequences in an accident. Therefore, regular inspection of the ABS sensor is essential. Sometimes, tiny iron filings may adhere to the sensor head. Where do these filings come from? The first source is the brake disc. When brake pads wear down the disc, they generate fine iron filings. The second source is the external environment. For instance, dirty roads can produce iron filings mixed with dust. Observe the toothed ring in the circle. It has holes evenly distributed around its circumference. Now observe the sensor's mounting position. A clearance must exist between the sensor and the gear ring, maintained between 0.3 and 1.8 millimeters naturally. This clearance varies across different manufacturers and vehicle models. Specific requirements should be checked in each manufacturer's maintenance manual. For example, the gap for the Honda 150 is between 0.57 and 1.08 millimeters. This means the gap between the gear ring and the sensor head must be maintained between 0.57 and 1.08 millimeters. The purpose is to allow the sensor to clearly detect the rotational speed of the gear ring. If the gap is too large, it won't be able to detect it. Additionally, the gear ring is never perfectly flat if the gap is too narrow. The gear ring may occasionally scrape against the sensor head during rotation. Therefore, during installation, it is crucial to measure and ensure the gap between the sensor and gear ring meets the specified standard. Regarding the sensor's installation orientation, the screw hole and sensor must be directly above the gear ring, ensuring the gear ring and sensor remain perpendicular to each other. After discussing the sensor clearance and installation requirements, let's now cover the testing method for this sensor. First, we'll still use the pipe pressure drop method for measurement. I have two ABS sensors here, both 2-wire types, compared to 3-wire sensors. They simply lack a shielding wire. The measurement method remains the same. Ensure the multimeter is set to the diode test function. The reading should display approximately 0.400. Switch the leads and the reading should show around 1.130. These two measured values should not match. If they do not match, the sensor functions correctly. If both readings are identical, the sensor is faulty. Now let's test another ABS sensor to see its values. One and reads approximately 0.340, while the other shows around 1.010 again, one high and one low. Next, we install both sensors onto the electronic fuel injection simulator to verify the front wheel ABS circuit functionality. The voltage between the white and blue wires measures approximately 10.5 volts, indicating the battery voltage. We also confirm continuity between the white-blue wire and the ground wire. Next, check the rear wheel ABS shield wire and ground wire for continuity. Measure the voltage between these two wires, which should be around 10.5 volts, indicating the battery voltage. This confirms the circuit is functioning correctly. Third, use a screwdriver to touch the probe and observe the voltage. When touching, the reading is approximately 10.43 volts. When moving away, it reads around 10.6 volts. The voltage fluctuates as the screwdriver approaches and retracts. Testing with the gear ring shows similar voltage variation, confirming the sensor is functional. Fourth, the clearance between the ABS sensor and gear ring requires periodic inspection and measurement to ensure it remains within the standard range. We typically use a feeler gauge to check this clearance. Excessive or insufficient clearance is unacceptable, as both will impair normal ABS operation. Fifth, fault code diagnosis. Observe that when the vehicle's ABS malfunctions, the dashboard fault indicator light will illuminate continuously or flash. Simply follow the fault code reading procedure or use a computer diagnostic tool to detect the cause. Consult the manufacturer's repair manual for the fault code table to identify the issue. It's very straightforward. The above outlines the testing methods for motorcycle ABS sensors. Thank you for watching.